from one modality to another modality, text to image, image to text to video, amino acids to proteins, to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one job only, generating these incredible tokens that we then reconstitute into music, into words, into videos, into research, into chemicals or proteins. We reconstitute it into all kinds of information of different types. The reason for that is because for all of you who've been coming to GTC all of these years, you've been listening to me talk about these libraries this whole time. This is in fact what GTC is all about, this one slide. And in fact, a long time ago, 20 years ago, this is the only slide we had. One library after another library after another library. You can't just accelerate software, just as we needed an AI framework in order to create AIs, and we accelerate the AI frameworks. You need frameworks for physics and biology and multi-physics and all kinds of different quantum physics. You need all kinds of libraries and frameworks. We call them CUDA-X libraries, acceleration frameworks for each one of these fields of science. And processing, lithography, computational lithography, which is the second factory in a fab. There's the factory that manufactures the wafers, and then there's the factory that manufactures the information to manufacture the wafers. Helping them research on quantum architectures, quantum algorithms, or in building a classical accelerated quantum heterogeneous architecture. And so really exciting work there. Equivariance and Tensor for tensor contraction, quantum chemistry. Of course, this stack is world famous. People think that there's one piece of software called CUDA, but in fact, on top of CUDA is a whole bunch of libraries that's integrated into all different parts of the ecosystem and software and infrastructure in order to make AI possible. I've got a new one here to announce today. QDSS, our sparse solvers, really important for CAE. This is one of the biggest things that has happened in the last year. For structured data, we now have a drop-in acceleration for Spark and drop-in acceleration for Pandas. Incredible. And then we have Warp, a library for physics that runs in a Python library for physics for CUDA. We have a big announcement there. I will save it in just a second. This is just a sampling of the libraries that make possible accelerated computing. It's not just CUDA. We're so proud of CUDA. But if not for CUDA and the fact that we have such a large installed base, none of these libraries would be useful for any of the developers who use them.